Hold on now. I'll make it more dramatic. Ta-da! So we're going to have a look at histograms. The biology students know all about histograms, don't you?
You know what they are.
We've never actually known.
What? You've never drawn a histogram with Colin?
No.
Are you sure?
Yeah.
Because I can ring him.
I'm positive.
Yeah, sure.
No, we did. I think we did.
Quiet, Ollie. Don't tell him. No, really. Really. Did you or not? Did you not?
Learn is
Like, I mean, did he ask you to draw one? No. Well, he showed you one.
Yeah.
And he showed you how to draw it?
No. Yes, it's like sharp and light.
You don't do it right.
Quiet. What are you saying? Did he show you how to draw it?
Not exactly, no.
Okay. He did a kind of rough explanation, was it? The book showed you. Right, that's fine. So I'll show you how to draw a histogram. So first we'll need some data. So again, we'll just do something like with heights. First, I will show you the biology way, which is the wrong way, so bad. Then I'll show you the right way.
Which is the math.
Yes, the right way. Okay, so here we're talking about heights, and here we have our frequency again. So let's, again, we'll use the same numbers. What did I have for the heights? 130, was it?
Yeah.
130 to... Yeah. 140 to 149, 150 to 159, 160 to 169. And what numbers do I have here?
No, the total was 7, so it was...
What was it? Okay. So if you were in biology class, Colin would say, this is how you draw a histogram. You mark your numbers here, like for example 130, and then here's 139, and then here is 149, etc. And then what would the height be? 3. And then what would this height be? 4. And then the next one? 2. And then the last one?
1.
So, easy way, and also wrong.
Then what do they teach us?
Because in biology, there's a lower standard for graphs. It's true. It's true. It is, yeah. Yeah, that's how I say. So this would be the column way. Now, in fairness though, a lot of books would actually maybe draw it like this. But to be clear, this is not really a histogram when we draw it like this. Okay, this is more like a bar chart of some kind. It's not really a histogram. And I'll show you what we should be doing for a histogram. Yes.
There is a line, trend line.
Trend line?
Yeah.
Oh, no trend line for us. You would have a trend line? Maybe some line on it like this? Yeah. We can add that in later, but it's not called a trend line though. But I know the one you're talking about. Anyways, before we start, the first thing we want to make clear is what is the lower and the upper boundary in each bar. So I'll have a lower and an upper here. So what's the lower for this one?
It's 120 number.
Lower.
129.5.
129.5, and this one will be 139.5. And this will be 139.5, and then this one here, 149.5, 149.5, yeah, and so on. Okay, so let me just extend it. So just like with the cumulative frequency, we have to extend our table and add in extra information. Have you got that? Now, for this last column, we want the height of the bar. We want to know how high the bar is. And it's not quite 3, 4, 2, 1. There's actually something else as well to it. We should also work out what the width of the bar is, how wide it is. Now, it's actually the same in each case. It is 10 units wide. 10 units wide, 10 units wide, and 10 units wide. Now we can work out the height. And the symbol I use for height is not H, although you can use H if you want. I'll use this symbol here for height. So just to be very clear, the height is not the frequency, as might be the case in biology. It's not the frequency. In fact, the height is equal to the frequency divided by the width, which doesn't seem like a big difference, but it's an important difference. So what would be the height here? No, you're thinking like biology students. Try again. Thank you. 0.3. Here? 0.4, 0.2, and 0.1. I'm using this formula here for the height. Now the advantage here is that we don't have to use the same width each time. In my data they are 10 apart, but they could be different widths. This is another difference between the bar charts in your bio class. Your bars are always the same width, isn't that right, when you saw them? Although there's no problem in maths whatsoever if the bars are of different widths. Although it's unusual, it's not a problem. In this example here, all the widths were 10. And in fact, in the exam, this will probably be the situation as well. Okay, once you have that table drawn, I can make the graph. Do you have this table? Yeah? Okay. No CF for this. No CF. Okay. So what is my so just to be clear, what I need to use for my graph is the lower, the upper, and the height here. Is what I need for my graph. Okay. So my lower starts at what value? 129. So I don't start at 0, I skip a little bit, and I start at 129.5. And then what's my last upper?
169.5.
So we can do I need a bit more space. This can be 129, 139, 149, 159, 169. Is that the last one? Mm-hmm. Yep. So this is 129.5 and it goes all the way up to 169.5. And this was height, wasn't it? In centimeters. And notice here, again, I'm skipping at the start by this symbol. Okay, what is my biggest height?
0.4.
0.4. So I'll just mark it off like this. 0.1, 0.2, 0.3, 0.4. Now this 0.4, 0.1, 2, 3, and 4, let me just go back up here. What exactly is that? I mean, it's not cumulative frequency, it's not frequency, it's kind of like the frequency, but it's not, because I divided by 10. This is actually called the density. I'll explain what that means now. Yeah, I mean, I know the physics students have no problem with density, mass per volume, and it's kind of a similar idea here. It's the number of students per gap. So, for example, here, how big is this class? It's 10 units big. And how many people do we have in this gap of 10? So the density is 3 per 10 in this piece, or 0.3. In this one it is 4 in 10, 4 per 10. This one here is 2 per 10 and 1 per 10. So this is what I mean by frequency. It's like how many per unit. Again, another example will make this a bit clearer, but don't worry too much yet. What is the first height?
100
No, the first height.
100.
Well, first height. Thank you. 0.3. What is the second height?
0.4.
The next height?
0.2.
0.2. And lastly, 0.1. Now, I don't have the numbers here. You should. I don't have space. This one will be 149.5. As an example. These bars must touch. See? They must touch. Now, here, I'll squeeze it in here. Let me zoom in. 139.5, 159.5. Okay. So what I want you to calculate for me is I want you to tell me what is the area of this bar calculated. How big is the base? 10. And what's the height? So what's the area? Yeah, which is 3. Now what's the area of this bar?
4.
Yeah, 4. What's the area of this bar? 2. And what's the area of this bar? 1. Have we seen these numbers before?
Yes.
Yeah, what are they? Yeah, and this is the important thing about my histogram versus your biology histogram. In maths class and maths exam, the histogram, it is the area that represents the frequency. So here we have the area is what represents the frequency, and not the height. This is the reason for this calculation here. We calculate the height like this to make sure that the areas represent the frequency. And this is really what's the key difference between the bio and the maths histogram. In fact, I hope you realize that if the widths were 1, yeah, well, what happens if the width was 1 here? What would be the height? It'd be 3. Because 3 divided by 1 is 3. So you can see that it would make the same graph as what you have in biology then. So it's not like what you have in biology, it's completely different. But we just need to be more particular in maths. And this is the key for us, that the area is the frequency. Okay, have you drawn that? Did you draw that, Omar? With the numbers inside? Mm-hmm. Yeah? Yeah? Okay. Why are histograms useful? What can we do with a histogram? Let's have a look. So if I said to you, in this classroom, here's the data, how many people are between 130 and 139 centimeters in height? How many people are between 130 and 139? 3 people. How many people between 130 and 149? 7. 130 and 149 is 7, yes? Now suppose I ask you a question like how many people are between 145 and 165? You can't answer it from the table. If I said between 145 to 165, how many people? You can't tell from this table, true? But you can't tell from the histogram. What you do is you mark off 145. Where's 145? There's 149, 139.5. So can you see that here would be 145? Yeah. Where's 165? That would be here. So what you do, if you want the frequency, how many people, then you need to calculate this area. Hold on. Well, not triangle, but you want to calculate this area. Oh no, too far. That's the area you want, because this area between 145 and 165, if you calculate this area, you know how many people then. Because remember, area is frequency. So I'll break this up into 3 rectangles. It'll make it easier, because this middle rectangle, we already know its area. What is it? It was 2. Now this rectangle, how big is this piece here? About 5. Because it's about in the middle. So 5, and what's the height? Was 0.1, so what's this area? 0.1 multiply 5, 0.5. Now how big is this base? It's 5, and what's the height here? 0.4, was it? So 5 multiplied 0.4, this one is 2. So the total area would be 4.5. So you can say the number of people between, what was it, 155? 145 and 165 centimeters. The frequency is roughly, what do we say, 4.5. So you know, about 4 or 5 people are between these 2 heights. And this is the type of question that you would get in the exam for using your histogram. So they would ask you to draw a histogram, and then they would ask you to do something that means you have to use your histogram. Okay, so please make note of this. So the histogram, it can allow us to calculate frequencies which are not on the table. The cumulative frequency polygon can allow us to calculate quartiles and median. Okay, so these are the different applications from each graph. This is very useful because if you have hundreds and hundreds of pieces of data, if you've got a computer program or something to put into a graph, it's easy to read off what the lower quartile is instead of having to rearrange the list in order. And likewise, if you have hundreds and hundreds of pieces of data and you said how many are between 145 and 165, you don't have to count. You can look at it from the graph. So the graphs provide useful summaries of the data, especially when the data is very large. Yeah. Now, what I'm going to do is I'm going to stick the next lesson onto the end of this lesson, because for the last lesson I did make it a worksheet in the book, but it really was probably me being over the top. It doesn't need its own worksheet, and in fact for the exam it only needs a small piece of information that's usually 1 mark. So we'll just go straight into the next topic, which is just describing your histograms. Now you can stay on the same page, you don't need the last worksheet. So your histograms can come in different shapes and sizes, and there's different vocabulary for describing them. So let's have a look. Oh, and just to make my life a little bit easier, I think this is what you're talking about, Ali. We can draw a line on the histogram to kind of represent the shape. So rather than me drawing boxes, I'll just draw a smooth line. But please remember, it should be boxes. Okay. So the first possibility is your histogram looks like this. It's flat, it has a hill shape to it, and then it goes flat again. In fact, this is just called a normal histogram or a bell curve histogram. The reason I'm giving you this vocabulary is for 1 mark in the exam, they may ask you to describe your histogram. So if your histogram looks like this, you can say, my data is bell-shaped. Yep. Okay, can I scroll down? Oh, come on. Okay, I'm scrolling down now. Next, you could have something like this. Histogram goes up, then it goes down a little bit, but comes back up for another maximum, and then goes down. So this one is called a bimodal histogram. Bi because there's 2 modes. You remember what mode is? What's mode? What does mode mean? Most frequent, yeah. So if you have 2 big fat bars here, and then smaller bars to the side, this one has 2 modes. This is a mode and this one's a mode. There's 2 maximums. This is bimodal. Okay. By the way, now that you've seen the vocabulary for this, I hope somebody can realize another piece of vocabulary I could use to describe the last one. Huh? No? What? Say again? Oh, you're so close. So close. Not monomodal. But you're so close. Huh? Trimodal. That's right. This has 3 maximums. No, you're not. Just think for a minute. How many maximums does this have? 1. I'm sure it was close when she said, what did you say? Monomodal. Although mono's not the right prefix. Yes. Not single modal. Unimodal. He said trimodal. What? You might be able to fool your teacher back home.
No, I'm serious. I wasn't, I'm not...
You're being serious?
I was being serious.
I said, how would you describe this? And in your brain you saw... now we're getting to the answer then. So what you mean to say is you weren't listening to me?
Yeah.
That's okay. We'll continue now, once we're clear. Alright, bimodal. So, what would 3 be called? And so on. Okay, there's two more to have a look at. So sometimes your histogram might be imbalanced, so it could look something like this. Okay, this one here, we say it has positive skewness. So you can see that positive skewness if it has a fat tail on the left, or another way of saying it is a long tail on the left, and it's quite steep here at the right. Long tail or fat tail. Well, I suppose the normal vocabulary is most books would say a long tail. Okay, can I go down? Yeah, you're also smart. What's this one called? Oh well, congratulations. Negative skew, yes.
No, long was opposite side.
Long ones here, steep here. So if your histogram has this shape to it, we say it is negatively skewed. Yeah? Sorry, I don't have this. Oh, sorry, it's the same as this one, but turn it around. Okay, so we'll go to the last one. And a histogram that looks like this.
Equal.
Not bad, not the word though.
Symmetric.
Oh, we're getting great answers, but not this either. Not symmetric, not equal. Rectangle, not bad, not this also, when all the bars are the same. See, these are all great answers, but none of them are right. Keep going.
Uniform.
Wow. Yeah. Uniform. So this histogram is uniform. Okay, you got that? So again, this is really only for 1 mark in the exam. After you draw your histogram, they may say, describe it. And since it's only 1 mark, you need only 1 sentence. So here you could say, the histogram is uniform. And that's it, that'll get you the mark. Okay, so you have uniform, negative skew, positive skew, bimodal, or unimodal. I don't know, I thought this vocabulary was used in the biology class for histograms? Or is this new vocabulary?
Like you just told us this is the histogram, you don't need to know, just move on.
Just like that, huh?
Yeah.
Okay.
We didn't actually take a lesson on histogram.
Will you take a lesson on it? Because they do ask you in the bio exam sometimes to draw histograms. I've seen it before. It is easy. It's very easy. Yeah? All you need to do is make sure you remember this formula, that the height of the bar is equal to the frequency divided by the width. And make sure that your bars touch. And that's really it. You can't mess it up. Some of you will impress me and mess it up. But really, you shouldn't be messing it up. Yeah, it makes when I'm correcting the exam interesting to see how people mess it up. But you shouldn't. So in the exam, section B, usually the last question is the statistics question. And every single year, there's only two possibilities for the statistics question. Either they will give you data and ask for a histogram, or they will give you data and ask for a cumulative frequency graph. That graph can be a curve or polygon.
Do you advise us to do this?
You absolutely must do this question. Yes. Everybody should do the statistics question. If you don't, you'll disappoint yourself with a lower result. You absolutely must do it. And when you look at the grades people get, they get between 10 and 15 out of 15. And in fact, I'll be honest, if you get 10, it's kind of disappointing, because there's no reason you can't get the full 15 here. Okay? When you look at the graph question, you've got your choice here. It's either going to be a histogram or cumulative frequency, and the cumulative frequency will either be the polygon or the curve. And in fact, when you look at what they usually ask you, 5% of the time will be this, 95% of the time will be this one. And in fact, you're looking at 90% of the time is this, and 5% of the time is this one. So you've got a really good chance of knowing what the graph will be. It'll probably be this one, because that's what it usually is. But just remember, maybe they'll ask for the curve, it does happen sometimes, and maybe they'll ask for the histogram, it does happen sometimes. This one here has appeared twice recently, so I think it's a little bit more popular. So I wouldn't be 100% sure to say it will be a polygon for you. I can't remember what it was. No, I do remember what it was for the September students, yeah. Which, will I tell you or not tell you? No, find out next week. Yeah. Could be this, could be this, could be this. And I suppose technically there is one other graph they could ask. What's the other one? We did it, yes, last class? Line graph, which has been asked 0%. And this will be based off of 14 exams that I've done. Well, nearly 14. You will be number 14, I think. So, don't screw it up. You should get 15 out of 15, okay? The way the question usually works is the A part, they give you some data. The B part, they ask you for calculations like the mean or standard deviation. The C part, then they ask you for a graph, and then the D part is they ask you for something from the graph. You have to use the graph. And the marks are usually something like, I don't know, 5. Oh, sorry, well, they would ask you, they give you the data and ask you for the mean first. So that might be like 3, 5. Yeah, and then 4, something like this. So you can see actually, really the graph makes up 9 marks because you have to draw it and you have to use it. And these calculations aren't too difficult either. The place that people make the mistake is usually here. They're not careful enough and they get the wrong answer. And then here, because their graph wasn't so neat, they get the wrong answer. And of course some people draw a bad graph, so these are the problems to look out for. So what I'll do is, I'll let you try the histograms for a few minutes, and then I will do some exam questions on this topic. Huh? I told you that this is the last lesson here. I just stuck it at the end of the histogram lesson. I put the 2 pages together, because I don't need a full lesson to describe all these possibilities. Yeah? Yeah. Alright. Draw a few histograms for me and then I'll do some past questions on statistics, section B.